I'd like to introduce and welcome up front J.R. Oakes from Adapt Partners, Director of Technical SEO, who's going to help us learn how to have fun with machines as AI rises and we learn to have fun with our robot overlords. So thank you very much, J.R., and enjoy.
Can you guys hear me okay? Sweet. All right. Thanks, Paul, and the whole Catalyst team for putting this together. This is an amazing conference. I was tweeting out that the first presentations here are probably better from a content standpoint than any conference I've been to that I can remember. So amazing job. So about me, that was hard. I studied industrial design at North Carolina State University, worked as an architectural glass artist for a number of years, came to development from there, which is really weird. I don't really know how that happened, but I did. And then went from into SEO because I just really enjoyed it. Raleigh's a really great area that has some amazing SEOs like us and Patrick and many others, Jenny Hallez. So it's a great community there. So to get started, I've read a lot recently about term frequency inverse document frequency, and I hate it. Term frequency inverse document frequency is an information retrieval mechanism that's going back years, and it's done well, but at a fundamental level, term frequency inverse document frequency is just counting keywords on a page. It's not even the best information retrieval algorithm. There's one called BM25 that takes into account document length, meaning that if you have, it's not just the frequency of keywords within a document, but if you have a shorter document that has more density of those keywords rather than a longer document that has the same density, the shorter document will return. In addition, has iterations that take into account things like link graph information. Really interesting for nerds that read a lot about machine learning is like Wikipedia has made this transition from term frequency inverse document frequency in 2016 to BM25 in 2016, and then now they're actually trying out machine learning models and seeing how that affects their search result. So I have two links here that you guys can see when I share the deck. Really interesting information. Just going through, 2 years ago, and looking at the impact of BM25, and then coming now and seeing the impact of actually applying machine learning to those results. So that interesting note here, we found that users with machine learning ranked results were statistically significantly more likely to click on the first search result than users with BM25 ranked results. So they're proving out here pretty significantly in their first try that applying machine learning algorithms to information retrieval does better than what currently exists. So the really interesting thing about this is that they publish their models on GitHub. So you can actually go and look at the feature collection that they have from each of the pages, the link, graph information, click information, and then they use a really popular machine learning algorithm called XGBoost. That's the darling of Kaggle competitions. Almost every one of the Kaggle competitions from the last several years at some form implements XGBoost. Normally with respect to, they'll normally put together use XGBoost as well as certain other machine learning algorithm networks in an ensemble, but XGBoost is something that in a lot of the machine learning competitions, at least on Kaggle, has been a part of the best representations. One additional thing, XGBoost is it's gradient boosted decision trees, and benefit of XGBoost in comparison to neural networks is that you get some intuition and you can actually dial in and see how the algorithm is making decisions, which is something that's been difficult up to this point with things like recurrent neural networks. This is, I can't even pronounce that. I don't think you're meant to be, but they have their whole Python Spark library for handling that whole training process on Wikipedia. So I really like looking at companies like Wikipedia, and there was one called Common Search that I wrote about a year ago that are handling these information retrieval mechanisms, and you can get some type of intuition into how Google may be handling certain things on their end, although obviously it's not a direct comparison. So ultimately, we are way beyond term frequency, inverse document frequency. One thing you can do to think about that is if you have a corpus of documents and you're searching for the term baby, and in all those documents, the term baby never is there, but the term infant is often used, that won't be a very good retrieval mechanism because the keyword is not there. So what I argue is that there are methods that are publicly available today to look at kind of semantic matching of queries like baby to infant, and that you can use that information to make your content a lot more relevant than just basically keyword density. So how is Google using machine learning? Larry Kim wrote a pretty famous blog post. Was that on Moz? A couple of years ago, where he says that like click-through rate is what RankBrain uses to train its machine learning algorithm. Who here believes click-through rate has a really important impact in search results? Raise your hands. Wow, not a people. So this is what I do on my weekends. I like reading research documents from Google. They have a whole section called research.google.com that's broken up into like vision, that's broken up into search, information retrieval, Google Brain, really, and they just publish it there. And I can't read that. So this is one incorporating clicks, attention, and satisfaction model in a search engine results page evaluation. I'm not the first to show this. It's Bill Slawski. He wrote about this in December, and I was really pissed off when I saw that, but Bill Slawski is on top of everything. But it's cool here. While they're useful to the user to help search engines to stand out, what this is saying is, and you'll see in some of the other slides, that click-through rate is super important to help search engines measure how well their search results page are benefiting the user. The really interesting thing about this paper in particular is that with the evolving nature of Google search, SERPs, you can actually get the answer right there, right? So in past history, click-through rate has been critical, right? But now you get answer boxes. The phone will read off the answer to you. You might be putting phone numbers in your title tags. Somebody pulls their phone out and calls. So in the absence of clicks, how do you gauge whether or not that search result actually filled the need of the user? An interesting story is that my coworker, Robert Paget, noticed that on a particular page of our site, we had a graphic at the top, and it was responding to a particular query, and the page ranked really well. But the graphic gave the exact answer that the user, when they came to the page, and we're like, why are people only staying on this page 20 seconds, right? So we moved the graphic all the way to the bottom, and the time on page went up from like 30 seconds to like a minute and a half because people were actually reading the content at that point. Did that make it better? Because they were getting the answer before. They're reading more, but is there the same level of satisfaction? But I thought this was a really interesting model. And you can see that they look at and try to get a measure of clicks. Who here has used services like ClickTail or MouseFlow? May use MouseFlow? Like, I love using MouseFlow because you can actually put it on pages and you can watch people interacting with pages. And what they're talking about here, instead of just looking at clicks, they'll look at actual mouse movements, how people interacted with a page, and use those to predict whether or not people's attention was centered on particular elements of the page, and also end up with a metric of whether or not that search result page physically satisfied the user who was looking at that in the absence of clicks. So I thought that was really interesting. You can see here another page, learning to rank with selection bias and personal search, that click-through rate has been proven to be a critical resource for improving search ranking quality. In this paper, we study the problem of how to leverage sparse click data in personal search and introduce a novel selection bias problem and address it in a learning to rank framework. So obviously this is with personal search, which is a lot different than Google search, but there are some, I think there are some similarities, most notably that with Google search, they have segments of their search where they have just a tremendous amount of click data, which is more of your head term style queries, but they also have 15 to 20% that are queries that they've never seen before, or that they have really sparse click data for. So this is interesting in that it does tip the hat a little bit that Google is really interested in click data and how that influences their search engine results. And also this gives intuition in how they might handle extrapolating click-through rate to searches where they have sparse data on the number of clicks. And generally, this paper goes in to say that they group those queries together and the query result pairs together for these results so that they can create kind of more dense representations of the click data for those. So basically, click-through rate, or machine learning in its simplest form, takes a set of input features. It then uses an algorithm that processes those features in linear, nonlinear, or other tree-based ways to make a prediction, and an evaluation metric that compares the prediction to your ground truth data. So Google has the ability to collect a lot of different information about the query, about the context that that query is and the user is using. Obviously, there's a lot of information about the page, and then they also have mechanisms for judging the quality or give the ground truth of that data through the click-through rate or CAS models or the quality rater guidelines. The problem for us is we don't have the ground truth, we don't know the features, and we have no idea what is in these vector representations of training data, of hidden layers. But we do know that it probably depends on click-through rate. Bill Slawski's talked a lot about context models of adding context information, history of search, history of individual users, where you're located, to influence their ranking models. They have ground truth quality through the quality rater guidelines, and then they have other standard factors. So that's click-through. Storytelling, this is a recently published post. I pay attention a lot to machine learning, but particularly to one aspect of machine learning because it's a huge field that has papers coming out every day, it seems like. What I'm interested in is content, machine learning for content based usage. I love the fact that machines may be able to take huge amounts of content and distill that content down into something that's really informative and useful and tells a story, or that can actually create content from multiple different sources and do it in a useful way. So this is an algorithm or a model that's in a recent paper about storytelling. And the background of this is that, the goal of this is summarization. So summarization is one of the large goals of natural language processing in general for years. If you get into natural language processing, there's a lot of things that stalled out for years just because it's an incredibly hard field to master for a number of different reasons. But with a lot of the recent algorithms that have come about, like LSTMs and deep neural networks, it's covering a lot of ground and being able to make leaps and bounds there from a content creation and from a summarization perspective. This one's really interesting because it uses what's called generative adversarial networks, where it'll actually take in stories on the internet, stories, text stories, videos, etc. Try to learn how to tell stories from that data, in such a way that it summarizes a lot of different views and a lot of different news articles and a lot of different content. They use like the 9/11 attacks, they use the Charlie Hebdo attacks, so that they can basically take thousands of pieces of content and condense it down into something that's valuable for users. For us as creators of content ourselves, that should scare us a little bit because, in general, Google's going in the direction where they could take all of your content and create a page of content on a particular topic using, thousands of our hours, and no one would ever even see our original content. It's distilled something that's really useful for users. So that is something to look out for, but it's a really interesting technology. It's called a general adversarial network, but the premise of it is that you have have you guys seen those images online where neural networks have kind of created these kind of dystopian looking images? It's the same kind of thing here, is that you have a generator and you have a discriminator, and one generates and one basically says that's good or that's not good, and training that millions and millions of times creates something that kind of learns how to tell stories. So that gets us to LSTMs. I mentioned that before. LSTMs are my focus and what I really care about from a search or from a content perspective, because LSTMs give us the ability to learn long-term dependencies in content. The reason that's really important is that solves issues that have plagued natural language processing for years. It gives you the ability to actually generate content from a known corpus of content and do things like translation, summarization in a really smart way, rather than, I think the best ones out right now we'll just take a few key sentences from a document and then kind of put those together. Like, this gives us the glimpse of being able to take 150 documents on a topic and actually generate a coherent written sentence or document summarizing all of these other documents, kind of the thing with the storytelling. So from a content standpoint, it's something we should probably be watching, because you may be able to automate content in several years, and that would super change up the playing field. A couple of things with LSTMs, and I'm running out of time. Google just released a network a language frame semantic parser called Sling that actually fits into LSTMs. The really super interesting thing about that is that it normally with a natural language processing pipeline, you take a bunch of words, you tokenize them, you do tokenization of those words, you remove things like stop words, which are a, and the, and words that occur. You do part of speech tagging, you do dependency parsing, meaning that if you have he in a sentence, he refers to this other person. It basically takes all that entire pipeline and squishes it into one model that you can also connect up to a knowledge base. So if you know that much about machine learning, common sense is the big hurdle to make machine learning that we take for granted. Like, we know what an apple is, we know what all this what a chair is. A machine learning model may not know that. So being able to take these things and hook them up to the ground truth of Google's knowledge graph is pretty incredible leap forward from a potential standpoint. So what should we focus on? I'm going to run through these very quickly. Query disambiguation. This is a cool thing because, from Google's standpoint, they have to match up those two words to a lot of content, and there's really not that much information in the keywords that people are entering in. So you have to go through and look at kind of what the potential meanings behind that word when someone enters that word, and you can use those meanings to give a nudge about how you structure navigation, what kind of content that you put on a page, and really understand what 90% of your users meant when they put in Lipton tea. AT&T does an amazing job of this, and a hat tip to them because they have the same menu for mobile and desktop, which I thought was really super sweet. I just love that. Semantic relevance. This is from Google, Bill Slawski's talk. Knowing how Google's use context and semantically related phrases can improve the content you create and how well you optimize pages for particular queries. He goes on to talk about how Google knows the frequency with which words co-occur on the internet, so that you can build models that help understand whether documents are expert or not expert based on the ability to expect certain terms and also to know when certain terms are missing in documents about a particular topic. So it's really important to get beyond term frequency and start looking at, if you're talking about a baby, or writing the ultimate baby guide, you need to have a lot of different topics in there to cover that at an expert level besides just keywords. There's some way to handle this on a page level. Market Muse, I can't push them enough. They're amazing. SEMrush, and also some Python. So I'm going to run through very quickly a few notebooks that you can download. This is one that's fairly recent. I would say encourage you to download it and test it out. But one of the things that we do as part of our pipeline is we'll download hundreds of thousands of keywords for a particular website, And then we want to go and kind of categorize those from an intent standpoint or a kind of semantic relatedness standpoint. And this tool uses word vectors or pre-trained word vectors and k-means to be able to input a number of categories, run hundreds of thousands of keywords through it, and group the keywords into certain categories, which makes it really easy to do keyword research on. And that's the overall process. And you can see here, this is a cool thing. This is done on a local SEO website, but you can see how it assigns the SEO to my Google Maps, SEO to internet marketing, SEO company to my business, and such. So it's not keyword centric, it's actually understanding somewhat of the semantics of those words. The next one is click satisfaction. This is a representation of an article that Paul wrote last year or a few months ago? Yeah, on Search Engine Land. But it basically looks for click-through rate anomalies from your Google Search Console data so that you can just do a dump of your Google Search Console data, run the notebook on it, and then you can swipe off everything that's below like -1, and that's outside of what the median distribution of click-through rate is at the position for those queries. So it gives you a really quick target of what to target from to fix title tags, et cetera. The last one was a hat tip from Patrick, which this uses an algorithm called shingling, where you can crawl your site with Screaming Frog and pull the content of each page, run it through this algorithm, and in about 5 minutes it'll output your near match content through the site. So it goes beyond duplication. It'll actually show you the percentage near match of duplication across your site. So it's really quick, really easy to do. So that's it. I'm over time. Thank you.